Greetings, fellow grade 11s. It's Mr. Shajwayo here. Welcome to Back to Basics. What I want us to look at today, we are going to be still looking at our Euclidean geometry, and we are going to be attempting our exam type of questions, right? Now, let's look at this. They say, uh, in this particular figure, you are given that AB is a diameter of the circle with your center O, and also DC is a tangent, right? DC is a tangent, and then now they say chord AC is drawn also, and then D is a point on the tangent DC, so that angle what? So that angle A1. So they've given us that, so that angle A1 is equal to A2. So which means they are telling us that this particular angle is equal to this particular angle, right? Now, what is it that they want us to prove here firstly? So the first question is they want us to prove that AD, AD is going to be parallel to OC. So basically they want us to prove that these two lines, right? These particular lines, this one and these lines are what? They are parallel to each other. Okay. And now, one of the easier thing that you can do to prove parallel lines, right? Remember that from parallel, one thing that I want you to take note of, that the theorems that has to do with parallel is going to be your fan angles, right? It's going to be your fan angles. So which means you can either prove these angles that they are alternating. You can also prove the co-interior angles are, or rather you can prove, yes, the co-interior angles, you can prove the alternating angles, right? Okay. Now, so what is it that you're going to do now? Now this is corresponding, this is going to be the fan angles. So now let's see in terms of what is it that you can do now. Starting from here, one thing that I want you to take note of is that if you can look at this particular question, if you can look at AO, right? If you can look at AO and also your what? And your OC. AO and also your OC, these are your radii, which makes this particular line to be equals to this particular line. And now what is it that you can do now from there? So which means you can say now from here, if you can start by saying, now your 4.1, your angle what? Your angle A2. Your angle A2 is going to be equals to your angle what? Is going to be equals to your angle C2. Why is it that the case? Because remember, we are given that your OA is going to be equals to what? Is going to be equals to OC. These are going to be your radii. And what do that mean basically? So which means if this is your radii, which then makes your triangle AOC to be your what? It makes it to be our what? It makes it to be our isosceles triangle. And from an isosceles triangle, these particular angles that are opposite to equal sides, they are also going to what? They're also going to be equal altogether. So that's the first thing that I want you to take note of. Now, secondly, what is it that I want you to now take note of? Now, since angle C2, since angle C2 is going to be close to angle A, right? What else do you know from here? Now, we also know that you what? You are going to also take note of that now your angle A2, which means now your angle A2, right? Which means your angle A2, or rather your angle A1, or rather, remember this was angle A1. I want to get this was supposed to be angle A1, this particular angle here, and this particular angle. So your angle A2 here, your angle A2 is now going to be equal to your angle, what? There is going to be equal to your angle C2. Why is it that the case? It is because your what? It's going to be because your angle A1 is equal to what? Is equal to your A2. This was given to us, right? So which means if this angle C2 is equals to what? Is equals to your angle what? Is equals to angle A1. And angle A1, we are given that angle A1 is equals to A2, which means this particular angle is going to also be equal to this angle, right? So now this, we can now prove, or rather we can now conclude that yes, from here, our angle what? Our AD is going to be equals to what? Is going to be equals to, or rather is going to be parallel to what? To OC. Why? Because look at angle A2. Angle A2 alternate, right? Alternate with angle what? With angle C2. Altogether. So which means now we are going to say this is because alternating angles, right? Alternating angles are what? Are equal. Then That's going to be your reason for that. So therefore your AD is going to be that. So which means now if that is that, which means then we can conclude that your AD is parallel to OC. Are we fine? Now let's look at 4.2. Now in 4.2, what is that you can do here? Angle 4.2, they want us to do what? They want us to prove that our ADC is going to be equal to 90 degrees. So they want us to prove that ADC, this particular angle here, is going to be equal to 90 degrees. That's what basically they want us to prove. How can we go about proving that? Right? Now, let's start here. So now what is it that you can do now from here? Now, if you can look at your angle O, C, and also E, right? If you can look at angle OCE, this particular angle here, angle OCE, this angle here is going to be 90 degrees. Why is going to be that the reason, right? Your angle O, this is OCE. Remember, if you can look at your angle OCE, you are going to say your angle OC and also angle E is going to be equal to what? This is going to be equal to 90 degrees. What is the reason behind that? It's because tan is perpendicular to what? Its tan is perpendicular to radius. Altogether, which means now we are saying our tangent OC, the tangent OC is perpendicular to radius what? To the radius CE. Altogether. So basically that is going to be the reason for that. Now, what else now are we then going to take from here? So now, since this particular angle is going to what? Since this particular angle is going to be 90 degrees, what else can we take away from there? We are saying now our angle ADC, right? Angle ADC is going to be what? Is going to also now be 90 degrees, right? Now AD and CADC, this particular angle ADC now is also going to be equal to 90 degrees. What makes that to be equal to 90 degrees? If you can form your F here, right? If let's say we form our corresponding angles here, let me just fix that. If let's say we form our corresponding angles here, can you see that this angle here is going to correspond with this angle here because these lines are what are parallel to each other? Are we together? So which means then from corresponding angles, we can then conclude that our ADC is going to what? Going to 90 degrees. This is because of corresponding what? Corresponding angles. Why are they corresponding? Because AD is parallel to what? Is parallel to OC. And it is important that you mention the parallel lines as long as you are mentioning our fun angles altogether. So basically, that's going to be that as far as this angle is concerned. Hopefully this makes sense to you, and thank you very much.